Okay, right, to continue with our derivation for the efficiency for class B amplifier. So again, the equation was given. Okay, we evaluated this as P, this part, okay, which comes out to be VC max. Okay, we proved this. Okay, then we also evaluated this part, okay, which is P in DC. Okay, the only challenging term was to find I average. Okay, in the last slide we discussed about I average, how we can evaluate this. So this is the value of P in DC. Now you put in this equation these two values in, okay, in this efficiency relation. Okay, so P naught AC, okay, I can put over here. Now remember, what is the VCE maximum from the figure of, if you see the figure of the AC load line characteristics. Okay, this VCE maximum can be VCC. Okay, cannot exceed this VCC. Okay, what is the maximum value of IC? Maximum would be IC. Okay, okay, this will be IC. Okay, so I can replace these terms by VCC, IC, okay, divided by 4, okay, and then divide by P in DC. So this pi would go up. Okay, VC I put over here, this comes over here, and IC max again is IC. So now you can see that I can cancel out this with this. Okay, I can cancel out this IC with the IC. Only thing I left is pi by 4. Pi by 4. Now if I go there and if I write calculator, sorry, if I write is calculator, I open my calculator. Basically I want to show you that how we can, pi by 4 is equal to how much. So I can go there, I can say pi, so pi goes to be over here, and divided by 4. So pi divided by 4, which is equal to 78.5, okay, percent, 0.78. So I can, okay, I can put it over here, sorry, okay, this is my PowerPoint over here. Okay, so it means that right, okay, so this is 78.5%. now recall the value is efficiency is 0.25 for class A amplifier. So it means that class B amplifier is more efficient. Okay, it is more efficient as class A amplifier. In class A amplifier, okay, only this percent of power is delivered to the load, which is 25%. The rest 75 is dissipated as heat. Over here almost, this is, if I say, approximately equal to 79%. okay, so it means that 79% of the power is delivered to the load, the rest 21% is dissipated as heat. Now this is not available, this derivation, in the book. So what I do, I can I took it from this reference. Okay, so can you go and you can also YouTube it, and you'll find the complete derivation for the efficiency of class B amplifier. So the same as I told you over here. Now this is okay. Now this class B amplifier, this typical class B amplifier circuit is given. Okay, this is the output of class B amplifier. Okay, now we see the disadvantage is what? The disadvantage of class B amplifier, there is no linear reproduction of the input waveform. So this waveform is missing. So what we can do, if we can take another class B amplifier like this one, okay, another class B amplifier, and somehow, okay, we operate, okay, this one and this one in such a mechanism that the overall, okay, the overall waveform, so for the first half cycle this would conduct, okay, for the first half cycle, and then for the negative half cycle, okay, this would conduct, the other class B amplifier would conduct. Okay, so we call this combination as what? As push pull. So okay, the solution, so it means to address this advantage, okay, of of this disadvantage of class B amplifier. We actually combine two class B amplifiers, and the combination of the circuit is known as push pull. So for one half cycle, okay, to add, so it is necessary to add a class B amplifier over here, so that it operates on the negative half cycle. Okay, so this is push pull mechanism, we call it. Okay, so it is very simple. Now the question is, how can we add, okay, another amplifier, class B amplifier? Okay, so what should be the architecture, or what should be the circuit formation when I add two class B amplifiers to get a full wave operation? Okay, so for that, what we do, we go into the next slide and see over here. The first method is used is push pull. For the push pull amplifier is transformer coupling. Okay, transformer coupling. So this is illustrated in figure. So I remember I'm keeping the same figures as in the book. So this is figure 7.8. so how it is performed, okay, how it is done. So remember, this is one class 1 amplifier, class B amplifier, sorry, this is another class B amplifier. Okay, okay, now we have, okay, they are combined in this fashion. Okay, now if you see over here, okay, we have two center tape transformers. So one transformer is at the input, this is known as a center tape transformer. Okay, the secondary is, okay, and the center of the secondary winding is actually what is grounded. So we are not going to discuss the operation of this transformer in details, but how we can actually operate, or how can we apply, or how can we take this transformer to basically address our own issues, okay, to solve our problem. So and the second transformer is at the output, at the load. Okay, so basically these two transformers, you can say these are identicals. Okay, but at the input side, the transformer, basically this transformer would divide this input signal, okay, which is given by, okay, this input signal into two equal and opposite signals. So basically you can see this is two equal, okay, but opposite signal. Opposite in a polarity is different, polarity is out of phase. So this is positive for the half, and you can see this is negative for the first half. Okay, so these are equal and opposite signals, so it basically divides the input signals, the center tape transformer, into two. Likewise, okay, at the load side, which would basically what it would take, it would add two, so the operation is reversed. It would take two out of phase and equal magnitude signals, and it will give you, okay, it would actually give you into a single into one signal. Okay, so over here it was splitting the signal, over here it is combining the two signals. Okay, so this is very simple. Okay, the 2 NPN transistor, okay, you can see this is 2 NPN transistor. Okay, no DC biasing. Remember, again, there is no, can you see DC biasing? No, there is no DC biasing in the base, so it means that is a typical class B amplifier. Now the only signal voltage drives the transistor into conduction. Okay, so whenever the signal comes, okay, the signal comes basically over here, or maybe over here, okay, remember, over here, so it would push this amplifier into conduction. Okay, either of the amplifier into conduction. So what is the mechanism? Okay, over here if you see the mechanism, if I discuss about the mechanism, that how it operates, so it's well defined over here. So Q1 will conduct on the positive half cycle. Okay, okay, so whenever the signal is over here, okay, if you see this is the signal, okay, the signal is split into two equal and opposite out of phase waveforms. Okay, so this is positive, okay, the first, this is positive half cycle, this was the negative half cycle. Now remember, when this comes over here in this at this base, okay, when the value of this input signal gets greater than 0.7, okay, this conducts, okay. So when IB, there will be IB current flows, okay, IB current flows, okay, as a result of which current IC would flow, okay, IC, there will be a current IC, okay. And then, okay, we can from the collector, this is the collector, this is connectors to connected to some load, okay, to load resistance actually, okay. And this load is basically over here in this, okay. This connection is from the output transformer. So basically basically what happens that I can show this over here, okay. So basically this transformer, you can see over here, okay, this is a load somewhere over here, okay, this is RL, okay. So this is for the positive half, the first positive half cycle. And remember over here, this negative half cycle. So when it comes over here, okay, so there is no, okay, it cannot overcome this 0.7, okay, this barrier voltage base emitter junction, okay. So it is reverse bias, so there is no conduction at the output in this part, okay. Now when, okay, this negative half cycle comes, right, okay, so again things will be reversed, okay. Q1 will be pushed into non-conduction, Q2 will be pushed, okay, into conduction, because, okay, the polarity of this will become positive, the polarity of this will become negative, okay. So we would see, okay, that Q2 would conduct, and because of this 2 conduction actually IC would go flow, it would flow, and we would have we can take out a signal or voltage from the collector through this transformer to the load. So basically the both of the transistors Q1 and Q2 are basically operating for one first for the positive and then for the negative. So the combined effect you can see is a full wave, okay, is a full wave amplification.